Hello and good morning, students. I will be teaching you a new term which is named as impulsive force. As we all know, force is any kind of a pull or a push which produces some kind of motion or changes the state of rest or a state of motion of any particular body. So, before that, let's derive a relation for to show that the Newton's first law of motion is contained in the second law of motion. After that, we are going to understand how the force is related to the term impulse. That means the product of force and time, and what actually this impulsive force is. So, students, see, according to the Newton's first law, it has been stated that if there is no external force acting on a body, the body will tend to remain in the state of rest or uniform motion. So, if we consider that the force is zero, okay, now from the second law of motion we understand the force is the product of mass and acceleration. Okay, students, now if we put the value of force as 0 in this formula, the acceleration will come out to be as 0. Okay, now as we know, the acceleration is the rate of change of velocity, so the acceleration is v minus u upon t, which is equal to 0, and the t will be transferred to the right hand side, so the v minus u is equal to 0 will be come out. In this way, if we transfer u to the right hand side, the v will come out to be equal to the u, and we know that the v is the final velocity and the u is the initial velocity of a body. So in this way, this means that if no external force is applied on a moving object, then its initial and final velocities are equal. That means the body is not moving, or it is in the same state of uniform motion. In this way, students, we derive the first law of motion is contained in the second law of motion. Now, let's understand what actually the type of force we are talking about as an impulsive force. So, students, the force which acts on a body for a very short time period, like in the case of this rugby match or a football match, when a person is defending the other player to move forward or hitting a goal, so they collide with a very high force. So this kind of a force is termed as an impulsive force, and this force acts for a very small interval of time. And if even we can understand this in the case of a batsman hitting a ball. When the batsman hit a ball, the contact or the collision time between the bat or the ball or these two players, is a very short time period. That means, suppose we consider while hitting a ball by a bat, the time of collision is about 0.01 second. But the average force exerted by bat on ball is several thousand newtons. It is very, very high force which is acting on a particular ball by the bat or this player to the other player. So this very high force which is produced in a very short time period, in a very short interval of time, this force is considered as an impulsive force. Okay, now in this way we will understand that the impulse is the product of force into time. Okay, now the impulse is the product of force into time, and the force in time we know that is equal to the total change in momentum. So in this way, the impulse is equal to the total change in momentum. Okay, and the I, that is the impulse, is equal to the product of force into time, and we know that it is also equal to the change in momentum, as I told you, because the force into time is equal to change in momentum. So in this way, the impulse will be mv minus mu, which will be mv minus u. So in this way we understand the impulse is a product of the force and time, which can measure the amount of force acting on a body, which is the impulsive force, which acts for a very short time period, for a very short time interval, and produces a very high force on that particular body. So in this way, the SI unit of the impulse will be considered as kg meter per second, because the unit of mass is kg, and we know the velocity is meter per second. So in this way, the impulse is kg meter per second, or the impulse can be considered as Newton per second. Okay, so the Newton has a unit that is kg meter per second square. So if we write the kg meter per second square, the second will be cancelled with the square of the second. In this way, the form unit can be kg meter per second or Newton per second. Okay, students. So this is the impulse of force. You can solve the numericals based on it, but the hardly it comes in the exams. So I'm not very considering a lot to explain you about the numericals related to impulse of a force. So we will be tomorrow. After the next week, we will be studying about the Newton's third law of motion. So please remember this derivation. It's very important to understand how the Newton's first law is related to the Newton's second law, as well as about the very special force, that is impulsive force, which is being used to measure amount the what is the contact or the collision of between two persons, or a bat or a ball, or any sport, or in any field, by a car or colliding a wall or something, to measure the collision as and the amount of impulsive force. We are using this term as impulse is equal to force into time. Okay, students, thank you very much. Thank you. I hope you must have understood this video based on impulsive force and the Newton's relation between Newton's first law and Newton's second law. Thank you, students. Thank you very much.